Here is a volume question that is going to involve integration by parts, possibly. So let's get to it. The question says we're determining a volume of revolution, and we're going to revolve this region. So we have the graph of y equals ln of x. Ln of x looks like this. We know ln of x goes through 1 comma 0. We have y equals 0, which is the x-axis. And we have x equals z, which is a vertical line on at x equals z, which is 2.718. And here's a key intersection point. If you plug e into the natural log, well, the natural log of e is 1, so this is e comma 1. So the region is right here. Where's my highlighter? So the region is right here. And we're going to revolve this according to the directions about the y-axis. All right, so in this video, I'm going to draw my representative rectangle like this, which means I'm going to do everything with respect to x. In the next video, I'll do it differently. So if I draw my rectangle like this, the rectangle is parallel to the axis of revolution, which means you have to use the shell method. The shell method is this. The volume would be 2 pi times the integral from a to b of, I think we call it h of x times p of x, I believe. Doesn't really matter as long as you know h of x is the height of the rectangle, the length of the rectangle, and p of x is the distance from the axis of revolution. So here's p of x. Here's p of x, and here's h of x. So here we go. So a to b is the length we're traveling along our shaded region. So we're starting at 1, and we're ending, this rectangle would end at e. So it's 1 to e. H of x is the height of the rectangle, which is, if you look at this length, that's going to be y because it's an up and down length. So you just take the top of the arrow point, whatever value of y is that is at, minus the bottom of the arrow point, whatever value of y that's at. So the top of the rectangle is on y equals ln of x. So h of x would be ln of x minus the bottom of the rectangle is at y equals 0, so minus 0. So h of x is just the natural log of x. P of x is this length right here. Since it's horizontal, that length is x. So that's it. P of x is x. At this endpoint of the arrow would be x. This endpoint would be x equals 0. So really x minus 0. And that's it. That's the volume. All we have to do is calculate that. So we're going to do that. We're going to do that as much as possible without a calculator. So right here, I'm seeing that we're going to have to use the integration by parts. So I'm going to move this down so we have a little bit more room. When you do parts, I don't know how to integrate ln of x, so I'm going to let u be ln of x, which means du is 1 over x dx. And that leaves, you have to, everything else has to be dv then. So dv would be x dx, which means when you integrate, v is 1/2 x squared. So now we use the integration by parts formula. So the integral of ln of x times x dx is equal to, the formula is u times v, so 1/2 x squared ln of x, that's u times v, minus the integral of v is 1/2 x squared, times du. Du is 1/x dx. So it's going to work, because you know it works when this integral you're left with is integrable, and that's just going to be 1/2 times the integral of x. Perfect, easy. So my antiderivative turns out to be 1/2 x squared ln of x minus integral of x is 1/2 x squared again, so 1/4 x squared. And that is my integral. It's a definite integral. So I'm going to evaluate it from 1 to e. And I can't forget that I have a 2 pi out here. So here we go. Plug in your values. When you plug in e, you will get 1/2 e squared times the natural log of e, which is 1. Minus 1/4 e squared. Minus. Now we're going to plug in 1. Well, the natural log of 1 is 0, so that whole first term goes out, becomes 0, and 1 squared is 1, obviously, so minus 1/4. So that's your answer. We're going to simplify it. We have 1/2 e squared minus 1/4 e squared, which is 1/4 e squared, and minus a negative 1/4, which is plus 1/4. Really makes sense here to factor out 1/4. So if you factor out 1/4, you get 2/4, or 1/2 pi. And then you're just left with e squared plus 1. So that is the exact area of that region. That was using the shell method. So it wasn't too bad, I don't think. What I'm going to do in the next video is do the same thing, but I'm going to use the disk/washer method on the next video. It might be easier, maybe not, but one thing for sure is if I did this correct, we will get the same thing. So, watch for that video, and I'll see you then.